All right, let's talk about a huge headache for pretty much any developer today: data chaos. We're going to look at a technology called ArangoDB that makes a really bold promise to unify your entire data architecture into one single, elegant system. Let's get into it. Does this sound familiar? You're building an app, and before you know it, you're trying to keep a document database for user profiles, a graph database for all their social connections, a whole separate search engine for your product catalog, and probably a key value store just for caching. Your architecture gets complicated, really, really fast. I mean, this is just the world we live in now, right? Today's apps have to be smart. They have to be connected. They don't just store one kind of data anymore. They have to manage these complex relationships, flexible documents, and get you instant search results all in the time it takes for a user to blink. So here's the game plan for today. We're going to start with the problem itself, this mess of data complexity. Then we'll introduce ArangoDB as the solution. We'll peek under the hood to see how its engine and query language work, explore some of its killer features, and then wrap up by talking about why this whole unified approach really, really matters.
Okay, so let's dive into that core challenge. There's actually a pretty fancy name for it: polyglot persistence. But don't let the name fool you. All it really means is using a whole bunch of different, specialized databases just to get one application to work. And while that sounds flexible, it usually just creates a tangled mess. And this slide just lays it out perfectly. On the left, you've got that tangled web. Every database is a specialist, sure, but you're spending all your time building these brittle, complex data pipelines just to keep them all in sync. It's expensive and a nightmare to maintain. Then look at the right. That's the ArangoDB way. It's not just cleaner. It radically simplifies your whole setup, keeps your data consistent, and honestly, just lets you build things faster. So if that's the problem, what's the fix? Well, this is where ArangoDB enters the picture. It's a database that was built from the ground up with one idea in mind: to be multi-model. The big idea here is actually pretty simple. What if you had one database engine that could natively speak multiple data languages? Since it's all one open source system, you can manage all this different data without constantly switching tools or contexts. That unification, that is the whole point. And what does multi-model actually get you in the real world? It means you get these 4 essential capabilities, all in one box. You can store user profiles as flexible JSON documents, map out their friend network as a graph, cache their session data with key value, and let them search for anything with a really powerful built-in search engine. Now, this all sounds great in theory, but you might be wondering, how does ArangoDB actually pull this off? Well, the magic is in its architecture. It's all about one engine and one language to rule them all. See, under the hood, there isn't one engine for graphs and another for documents that are kind of taped together. No, it's a single, highly optimized engine that inherently understands how to store, process, and query all of these different data models together. This is the secret sauce that prevents all that complexity we talked about earlier. And to talk to this one unified engine, you only need to learn one language: AQL. Now, if you've ever written any SQL, you're going to feel right at home. It's declarative, meaning you just say what data you want, not how to get it. But where AQL really shines is its ability to just effortlessly combine different data models in the very same query. Let's look at a quick example. Here we're just querying some document data. We're looping through a customer's collection and finding anybody who has more than 5 orders. Super clean, very readable, looks a lot like SQL, right? Okay, but now watch this. Using the exact same language, the same structure, we're doing a graph traversal to find a user's friends of friends. Now, the real magic here is that you could actually combine this graph query with that document filter we just saw, all in a single command. That's the power we're talking about. So let's dig in and see how this unified engine powers some incredible native features. We're going to focus on 2 of the biggest game changers: graph and search. Okay, so first, graph. Let's be really clear about this. ArangoDB isn't just a document database with a few graph features bolted on the side. It is a true native graph database. That means it's built and optimized for deep relationship analysis, finding the shortest path between 2 points, or spotting complex frog patterns in financial data. And then there's the built-in search engine, ArangoSearch. Honestly, this is a huge deal. It means you don't have to set up, pay for, and maintain a whole separate system like Elasticsearch. You can build powerful, relevant, and even location-aware search experiences right on top of your data inside the same database.
This comparison table really puts everything into perspective. While all these other databases are fantastic at what they specialize in, ArangoDB is the one that really stands out by bringing these key features together. It is natively multimodal, it has that integrated search, and it uses that one query language for everything. The goal isn't to replace every single specialist tool, but to consolidate the core functions you need most often into one powerful platform.
And this flexibility isn't just theoretical. It translates directly into amazing real-world applications. We're talking about everything from building recommendation engines in e-commerce to sniffing out complex fraud rings in finance or even storing massive knowledge graphs for AI systems. This combination of graph, document, and search is just incredibly versatile. So let's bring it all home. We've seen the what and the how. But now let's talk about the why. Why does a unified architecture like this actually matter for you and your projects? At the end of the day, the payoff is simple and it is significant. You slash your architectural complexity. That means your team can develop faster because they only have one system to learn and master. And your maintenance overhead, it just plummets. Instead of patching, securing, and scaling 4 different database systems, you're managing one. So if you're going to take away just 4 things from all this, let it be these. Number 1, one system means radically less complexity. 2, one language, AQL, gives you way more power across all your data. 3, having native graph and search makes it perfect for modern AI and machine learning. And 4, this thing is built to scale for serious enterprise-level work. Which really brings us to our final question. As our applications get more and more connected, more and more intelligent, the pressure on our data architecture is only going to grow. And sticking with that old, fragmented, multi-database approach, well, it might just be what's holding you back. So it's worth asking yourself, is your architecture ready for a more unified future?